Hello, happy January. Hope you're doing well and having a good new year so far. As we begin quarter three, I just want to remind you that you are starting on a fresh grade, a fresh slate. So I'm really excited. We are starting a new unit on solving systems of equations, but before we get to systems, which is two equations at the same time, um, we're going to spend a couple days reviewing how to graph an inequality, just to make sure we're ready. So these are notes one for the third quarter, called graphing linear inequalities. And then I just wanted to review to graph an inequality like this on a number line. If it's less than or greater than, we call this an open circle. And if it's less than or equal to or greater than or equal to, it's a closed circle. And then when we're graphing, we shade solutions. We shade parts of the graph that make the inequality true. So if we think about the numbers less than 3, that would be like numbers like 0, 1, and 2, and -3 and -4. All of those numbers are less than 3. So on my number line, I'm going to shade all the numbers that make it true. If I plugged in any of these numbers or any of the numbers that are shaded, it makes my inequality true. So that's a review. We're going to kind of use these concepts now to graph linear equations. So we're going to have lines like this. Y is less than 2/3 x plus 8. This line is in slope-intercept form, like y equals mx plus b. The y-intercept is 8. This is the slope, but instead of an equal sign, we have an inequality symbol. And so we have to deal with that. We graph it slightly differently. Just like with the regular inequalities, it's an open circle. When we graph lines, it's going to be a dashed line. So when you're graphing these, you're going to first decide if it's going to be a dashed line, or if it's underlined, it's a solid line. And then you have to decide where to shade. Just like with the number line up here, we had to decide if it was an open or a closed circle and to know which direction to shade. We have to do the same thing with these linear inequalities. We have to decide, is it a dashed or a solid line? And then we have to decide where to shade. And to decide where to shade, we're going to plug in the point 0, 0. We're going to plug in a point 0, 0, and we're going to look to see if it's true. Okay? All right, so we're going to do two examples. Just like always, if I'm going too quickly, press pause, and you can catch up. My marker went through. Oh my. All right, so for this one, if we remember y equals mx plus b, my y-intercept is 4, and my slope is 1/3. This is reviewing from all the way back before Thanksgiving break. So it's been a while since we did this. But my y-intercept is 4, so on the y-axis, I'm going to go up to 4. And then my slope is up, rise 1, run 3. So up 1 over 3. Up 1 over 3. I could also go down 1 to the left 3. And then I have to decide, now that I have my points, is it a solid or a dashed line? Because it's underlined, it's a solid line. So I connect these dots with a solid line. And then I have to decide where to shade. So my two questions are solid or dashed? And then where do I shade? And to determine where you shade, you're going to plug in the point 0, 0. I'm going to pause here, and please come back and watch the second video to see how you know where to shade.